Here we have a problem that's actually not a quadratic equation. This piece is quadratic, 2x squared plus 15x plus 18, but it's multiplied by a 5x minus 1. So this is actually what we call a cubic equation. However, we can solve this equation using the zero factor property. And what we're going to do is we can factor this piece here that looks quadratic. We can factor that first to begin with. So let's factor that. If we're going to factor this, we put two parentheses. And factors of 2x squared are 2x and x. And then we look for factors of 18, that when we combine this, we get 15 in the middle, 15x. Well, 6 and 3 come to mind. So we could put a 3 here and a 6 here. And you're trying out what you want to get is 15. And we notice here, oh, yes, I will, because I'll get 2 times 6 gives me 12 on the outer. And on the inner product, I'll get 3 times x gives me 3x. 12x plus 3x gives me 15. And they're both positive. So those are that's the factorization of the trinomial piece. And then we still have 5x minus 1 on the outside there. And these three factors, when multiplied together, give me 0. So we actually can now break this apart into 3 equations. Because if we have 3 things when multiplied give me 0, either one of these things can be 0. So in other words, 5x minus 1 can be 0, or 2x plus 3 can be 0, or x plus 6 can equal to 0. And then, so we have 3 linear equations. We solve each of these. And if we solve the top one, for x, we'll get x equal to, we add 1 to both sides, divide by 5, so x equals a fifth. That's one solution. The second equation, if we subtract 3 from both sides and then divide by 2, we get x equals negative 3 halves. And the third solution is if we subtract 6 from both sides, we get x equals negative 6. So we have 3 solutions, 1/5, negative 3 halves, and negative 6. Now we can actually apply solving quadratic equations to some real life problems, and let's do that. So here's one application of a quadratic equation, solving an equation. It says here, the height of a triangular sail is 2 meters less than twice the length of the base. If the sail has an area of 30 square meters, find the length of its base and height. Well, the first thing when you're solving an application is you have to define the variable. And actually, even before that, I would draw a diagram. So let's draw a triangle. So here's our triangle. And it says that the height of this triangle is 2 meters less than twice the length of the base. So let's let B equal the base. And so the height, what is the relationship between the height and the base? Well, the height is 2 meters less, so we're going to be subtracting off a 2, than twice the length of the base. Twice the base is 2b. So h is 2b minus 2. So we have b is the base, and the height is 2b minus 2. And now it says the area of this triangle, the area, is 30 meters squared. Now, area of a triangle, the area of any triangle is 1/2 h times b, 1/2 the height times the base. So we know our area is 30, and we know what the height is in terms of the base, and we know we have b for base. We can form an equation. So we'll let a equal 30 equal to, and then we'll have 1/2 h, but h is what? H is 2b minus 2. So we put in 2b minus 2 and then times b. So there's our equation. And this is actually a quadratic equation. If we multiply everything by half on the right side and by b, we get 30 equals 1/2 times 2 is 1. So we'll have 1b. And then 1/2 times 2 here is also going to be 1. So we're going to have b minus 1 times b. And then if we multiply everything by b, we'll have 30 equal b squared minus b. And so this is a quadratic equation. But we're not done. We actually have to solve this equation. So let's create a little bit more space on the board. So we have our equation, 30 equals b squared minus b. We need to make this into a quadratic equation. And generally, to solve quadratic equations, you move everything to one side. So in other words, this 30, I'm going to subtract it from those sides. In other words, I'm going to move it here. And so if we do that, what we end up with is 0 equals b squared minus b minus 30. Now, let's see if we can solve this. We can solve this by factoring. We factor here and here. We'll have a b here and a b here. And factors of 30, we want those factors to combine to a negative 1 in the middle here. So I'm thinking 6 and 5. And we want a negative 1 here, so we're going to have a negative 6 and a positive 5. And according to the zero factor property, b minus 6 equals 0, or b plus 5 equals 0. And so from each of these, b minus 6, if we solve that, we'll get b equal to 6. So our base is 6. If we solve the other one, b plus 5 equal to 0, we'll get b equal negative 5. However, we're talking about an application here. And this is a negative number. In real life, we're not going to have a negative base. So we can actually scratch this answer. And our solution is, my base is 6. My base is 6. Now remember, there was a relationship between the base and the height. So let's recap that. If the base is 6, and the height is twice the base minus 2. So we have the triangle here. Remember, the height was twice the base minus 2. 2 meters less than twice the base. Therefore, the height is going to be equal to, that we're going to use 6 for our base. It's going to be 2 times 6 minus 2. And so the height is going to be, 2 and 6 is 12 minus 2, 10. So my base is 6 meters, and my height is 10 meters.